Hi, so this is one thing that all students who are going to get a grade 9 or they're going to get a A-star are going to be doing. I'm not going to waste any time and keep you in suspense about that. It's that they finish resources. So they take packs of resources and they work all the way through. I'll come back to this a little bit later on because it's a live feed and hopefully some people will be joining us a little bit later on. But if you're watching this recorded, then I'll elaborate on that later on. They really finish resources. They don't leave stuff to chance. They cover specifications. They analyze their own performance, and they look at like mark schemes in absolute detail, and they really think exactly what they are expected to be doing. They're really quite precise in their thinking, and you need to be really precise in your thinking if you want to get the very highest grades. So we'll come back to that idea. If you're here early, awesome. I'm going to also talk about evaluations and also some of the new style of questions. And these are in the GCSE and A-level. So this really applies for GCSE and A-level. I'm not going to go into too high a level of detail. I just want to talk about one of the biggest principles in the kind of evaluations in these new specifications, and that is percentage uncertainties, right? So if you are asked to evaluate the methods or think of a way to improve a practical, I want you always to be thinking about these things: the absolute uncertainty and the measurement, and how they affect the percentage uncertainty, and be using those terms. Okay, if you reduce the uncertainty, i.e. by having a higher resolution, so if you make the difference in the uncertainty in the reading smaller, or you make the actual reading that you're taking, the measurement you're actually taking, the value of that bigger, then you reduce the percentage uncertainty. And that's such a huge idea for improving practicals. And I think at the minute, one of the best ways to get better grades than other people, and you are giving grades against other people, one of the best ways to do that is by really making sure you understand the experimental side of physics, because that's a lot of the new questions, the new style of questions, all about the experimental side of physics, right? I will have a little look periodically at chat. That's when I lean forward and touch my kind of phone screen there, because I'm just live streaming on my phone at the minute. When it gets to the half term, the Easter, I'll start doing some proper live streams as well, with a bit more detail and some exam questions. There's a fair few people here now, so it's really awesome. I'm glad you're liking physics. I'm glad that I'm making that impact for people. This one, well, I've done it again. People have been quite enjoying my live streams, and one of mine's done really well, where I mentioned how to get a grade 9 and an A-star. So this one as well is a really important set of skills, how to get a grade 9. The one thing that all kids who are going to get an A-star or grade 9 do is they're absolutely thorough, and they are absolutely finishing resources. Today, I actually sat and I set all the year 11s in my school. I set them the entire sets of caboodle assessments, and I did the same thing last year, and the kids who went ahead and did every single kind of caboodle assessment in this kind of revision for the actual exams, they were the kids, funnily enough, who got the A-stars. So I want you to take that home with you, okay? They were the kids who got the grade 9s. So if you do all of the bite size, or if you take home all of the topic tests you can get from your school, or I don't know if your school has Doddle or Caboodle or whatever, or the textbook, if you do all of the practice questions in there, then you're going to be really thorough and you're not going to leave any stone unturned, and you're going to do your best shot for getting the grade 9s or the A-stars. So let's talk about the two types of evaluation question that they're going to give you. Are either going to be a question about evaluating the methods somebody is using, so the actual practical methods using the apparatus, how to make that better, or it's going to be about evaluating the results. So the first question, when you think, okay, this is a hard skill, this is an AO3 skill, evaluation type skill, I need to either evaluate the method or the results. Which one is it asking me to do? If it's asking me to evaluate the results, I just look at the results. I don't need to think about the apparatus. I don't need to think about percentage uncertainty at that point. I just want to look at the results table. They're the easier ones, so I'll start with those really quickly. It's normally going to be about significant figures. The student has or has not recorded to a correct number of significant figures, and that number of significant figures needs to be consistent. At GCSE, you can think about it in terms of decimal places, but at A-level, you should really be thinking about significant figures. They boil down to the same thing in both of them. It's better, even at GCSE, to be thinking about significant figures. They need to be the same, but don't just say they need to be the same. Look for the data. Which one is not the same significant figure as the other ones? And I've seen that just in my A-level students' mock exams. A lot of them are saying, yeah, it needs to be the same significant figures, fine, but which one's wrong? What significant figures should they be to? Should they all be to 2 or should they all be to 3? And that might come down to the actual instrument that's been used to measure those things. It might be about spotting anomalies, so maybe they have included an anomaly when they've calculated a mean, or maybe they haven't included an anomaly when they've calculated a mean, okay? Or maybe they've, a really hard one might be that they've decided something's an anomaly and you don't think it is. So that is about the actual results. That's if you're evaluating the results table, look at the kids' results table and decide whether they've recorded or they've processed their data incorrectly. It's typically going to be something like, they've recorded 8.333 or something like that, and they only measured to 1 decimal place or 2 significant figures. So they should record to the same significant figures that they measured to, okay? So if you're evaluating the method, though, the main idea in evaluating the way kids have done things is this percentage uncertainty idea, right? So you take measurements, let's say you use a ruler, and there is an uncertainty in that. And if you're just talking about one measurement, you can see that as being a scale division, or you can see it as being half a scale division. And exam boards don't really mind; they'll credit you for both. Okay, so that is the uncertainty due to the resolution of the whatever meter you're using, the ruler or ammeter or whatever device you're using to measure something. The higher the resolution, the smaller the scale divisions. So a ruler has typically a scale division of 1 millimeter, that's its resolution. But a vernier caliper has 0.1 millimeter. So that has a higher resolution or a smaller uncertainty for an individual measurement. A micrometer has 0.01 millimeters. And so that, again, is a high resolution or a smaller uncertainty. That reduces the percentage uncertainty. So an answer might be use a vernier caliper because increases the resolution or reduces the scale divisions, so reduces the percentage uncertainty in a measurement. That also, if you've got results, that could be the range. So repeated readings are going to fall around a mean. So that could be the range or even half the range as your absolute uncertainty in that mean that you've got. Now, this is the actual value that you're measuring. And if you use the ruler to measure something longer, then clearly this overall fraction, which is the percentage uncertainty, is going to be smaller. So again, this applies for GCSE and A-level. The idea of changing your method so you reduce the percentage uncertainty by making something bigger, measuring a larger distance to get a more accurate G by freefall, for example, measuring a larger volume so that you get a more accurate measurement of your volume, okay? A lower percentage uncertainty. Now, accuracy comes down to how close something is to the true value. So you have this other percentage to calculate, the percentage difference. So percentage uncertainty is like how sure we are about our actual measurements, and percentage difference is how far away from the true value we are. And that is the accuracy. The accuracy means how far away from the true value, but it comes down to the choices we make about our methods, which make us more or less accurate. So a lot of times they ask you questions, just quite simple maths questions like calculate a percentage difference from this true value. And what they're really asking you is how accurate has the person been? Okay, so I hope that really helps you. Always bear that idea in mind when you're talking about evaluations. Always think, how can I reduce the percentage uncertainty, make the thing bigger, or make the resolution higher? Okay, so there's another type of question that I want to spend just a little time talking about they've introduced. And they've introduced a lot of new math skills into biology and chemistry as well to make them harder, but physics has kind of stayed the same. Somebody's asked actually how hard A-level physics is. Maybe you guys can pitch in like if you're doing A-level physics, do you want to tell Indian Gamer how hard you think A-level physics is? I think it's the hardest A-level, but then I think that once you start enjoying it, I don't think it feels hard. I want to talk about questions where they ask you to determine, conclude, deduce, evaluate, compare, and loads of other kind of similar kind of command words, right? Which is like, make a calculation and then compare to a value they've given. So it might be a kind of, here's a statement that a student's made or something, or here's a claim that a manufacturer's made about something. And you have to make a calculation and then say whether that claim is correct or not. That's an example of it. It might be compare the calculated value to a theoretical value. And essentially, loads of students are doing the calculation just fine, but then not picking up the final mark, which is just a little summation kind of sentence. And if you've done the new GCSE maths, which you will have done actually, then you'll have noticed they've put that idea into maths as well, because once more, these ideas are the same throughout the exam boards and throughout the GCSE and A-level, because the government, the QCA, the people who develop the curriculums have actually included it. They're the people to blame for these things. And you have to make a statement which includes a comparison of your calculated answer with the data quoted in the book. So it's actually a bit like that percentage difference idea. But I want you to think about your using your kind of crocodiles to make that comparison. So I want you to think about, is it much, much less than, or is it just less than? Okay, so using these kind of, these mathematical comparisons to actually do that. Is it equal to, or is it roughly equal to? So these two kind of symbols, you can write them in words. You don't have to use the symbols. In fact, probably best to write them in words. But just think like, okay, that's roughly equal to this thing. And I'll come back to this roughly equal to in a minute. Or is it greater than or much, much greater than? And again, you know those ones as well. So use those to kind of organize your thinking. I must, at the end of my calculation, I must make a comparison. Is this greater than or less than? Is it much greater than or much less than? So it's way out. It's 1,000 times greater than. And actually, that is a really good way to think about it as well. Actually, can you numerically compare that? Can you say that is 10 times greater than that? So no, the conclusion is wrong. No, it wouldn't be able to do that thing that they've said it could do. Things like that. For example, is it exactly like this? Is it exactly the same? Or is it roughly the same? And if it's roughly the same, can you say like, what percentage difference is it? If it's insignificant percentage that you've calculated, well, that's that, but that's only 0.03% of the value. So it's unlikely to be because of that. Something like that. So is it roughly equal to it, but how close is it? Now, I know I clickbaited you a little bit, and this is all about well, the one thing that all grade 9 and A-star students do, and that is that they finish resources off. So as I said, I set my year 11s today, I set them all of the caboodle tests. That's an online kind of, set of examinations, set of topic tests that students can sit and do. And I set them the entire test, right, to do in their own time as revision for the mock exams. And actually, it was the people that did all of them last year. Many people in my classes, they did some of them. They did maybe the ones they found most relevant. But all of the people who did all of the caboodle tests last year, they did every single one of those tests. And, if I look at the people, if I can take the people who did all of them, they all got grade 9s. Okay, and in my history, in my career so far, it's always been the kids who have come and said, right, I've finished this resource, what else can I do? They tend to be the ones who get the A stars. So you've got the revision guide at home, maybe you've got the textbooks at home. You can use my links down in the description to find the textbooks that I recommend. Get them and do them all. Okay, it sounds like a massive task, but I promise you, once you get the ball rolling, you'll be absolutely fine. I'll come back to any questions in just a minute. So they make sure they don't leave stuff uncovered. They make sure they cover every part of the specification. They're the type of people who print off the specification and go through with a highlighter or rag rate it, or they get those checklists and they go through and they make sure they know exactly what it means by every single one of those, and they maybe know which of their weaknesses and their stronger points are, and they spend time on the weaknesses rather than the stronger points. They cover everything, and this is the most important message that I'm trying to give you. They really analyze their own performance, and again, that's making sure they cover everything, and they really make sure they finish what they start. So they get their plan and they put it into action. And I know you guys can do that, and there's still time to do that. We've got Easter coming up really soon. I was talking in a live feed just recently, talking about making sure you hit the ground running at Easter, have a plan, what you're going to cover, and go ahead and do it. And then lastly, when they actually analyze their performance, they look in so much detail about the exact what the marks are for. They aren't looking for the answer, they're looking for the mark scheme. Where to get an A star or a grade 9, you need to be that kind of person. You need to be so carefully looking at those mark schemes and making sure you know exactly why one answer is worth the mark and another one isn't, because you don't want to be giving that answer that's almost right but doesn't quite get the marks. I'll have a quick look at the chat. If you've got any questions about that point, or you've got a question about percentage of uncertainty, or otherwise, then do ask. Caboodle tests. Mark says, third hardest subject, I reckon. After further maths and chemistry, you think chemistry is harder than physics, Mark? Away you go, Mark. Go on. Go to a chemistry revision channel. I'm only joking. You're very, very welcome. That's odd. I actually have a bit of an argument with our head of chemistry about which is harder, chemistry or physics, and you know which side I'm on there. But I think they're both hard, actually. I enjoy a bit of chemistry myself. XMAAXOX15 says, oh, caboodle test. So the topics, yeah, exactly. So, excuse me, I can just feel my throat going. Yeah, the topic tests, basically, like just going through and doing loads of topic tests. And the beauty of the caboodle, and I know Doddle does as well, is it gives you, marks it straight away and gives you feedback straight away, and allows you to be able to think about what your weaker areas and your stronger areas are. And then you can spend time with that. Caboodle, you also get the ebook on there as well, so if you don't know if you use Caboodle. But there's loads of stuff. I don't know whether I've set this XMAXOX. I don't know if you're one of our students at my school, but you're thinking, thank you so much for setting me loads and loads of tests. That's the type of student that's going to get the top grades. Destiny. When do you think we should be doing practice papers, since there's only 1 month left? Definitely now's the time for practice papers, yeah. I mean, you probably had 1 or 2 sets of mocks from your school. Revisit them first. As I say, use them to analyze your own performance, use them to think the bits that you're going to mainly focus on, use them to think about the gaps in your own kind of knowledge. You know, is it chemistry module 6 or something that you just still can't get? Spend time on that rather than the nice comfortable modules that you do get. A lot of people, when they start, they think, oh, I really like radioactivity, I'll start revising radioactivity first, and that just is the wrong way around. Okay, start with the bit you feel less comfortable with. Is that okay? So definitely time for practice papers now. I know there aren't loads of them out there. How many hours do you recommend doing every day in the Easter holiday? I wouldn't sort of not have a rest. I wouldn't work any more than maybe school hours. I would probably split my day into like 3 2-hour or 3 1.5-hour sessions, something like that. Whatever works for you. Smaller chunks more frequently if it does. But maybe spend like the middle of the day going out and playing football or something. Just don't become a robot. You need your human brain to, you know, to solve the problems in those exams as well. And what do I think of Seneca learning? And that's interesting. We were talking about that in the staff room just recently. You know, a parent who was also a teacher was saying that their son really liked using Seneca. I think I haven't actually checked it out. I really should, shouldn't I? And I think it's probably quite good knowing that like family. She's a science teacher, and if she said it was pretty good and is now recommended to her students, I think it sounds pretty good as well. There's loads out there now. Do go ahead and download the BBC Bitesize app if you haven't got it already, because that's really good for like really quick revision on the go. BBC Bitesize is great for coverage, I'd say. It's not necessarily great for the very highest levels. It's great to cover everything, but it's possibly not the very highest levels. But the Bitesize app is great for, you know, filling those little 5 minutes. What you need to do is catch yourself with 5 minutes on Instagram and say, no, 5 minutes on Bitesize right now, and Instagram for after the GCSEs. What else have we got? Some good questions, kids. Really nice to hear. Best GCSE revision technique. At this point, it's going to be past papers. I think the questions are the most important. If it's not past papers, then it's questions. Always be thinking question. Whether the questions are like, you know, if the flashcard is a question with an answer on the back, it's better than just a kind of bit of information. You're thinking question. So actually, if you wanted to kill two birds with one stone, then you could make flashcards, which were the kind of practice questions in a textbook, and the answers to them on the back. And then you'd have both, because you'd be thinking question, you'd be thinking question, answer. There's something that's always kind of rung true, there's some advice that I got when I was a kid. So you don't learn how to pass a driving test from a textbook. You don't learn by reading about it, okay? You learn by sitting in the car and doing it, okay? The only way to get better at pub quizzes is to do pub quizzes, and it sounds odd because pub quizzes are just like general knowledge, aren't they, right? But you start to learn how to get better at those questions rather than just improving your knowledge. And that is the case with GCSE and A-level exams. The best way to get better at passing those exams is by practicing the questions. That's not to say that all those 2 years you've spent have not been good and useful learning. There's a reason why, and if you see my Stop You're Doing Too Many Exam Questions video, there's a reason why we don't do past papers throughout the time. We don't just start and just do question the whole time. We actually do the experiments to get you the kind of knowledge and use that knowledge now to be able to solve the problems. Think about that exam paper as just a whole bunch of little problems you've got to solve, and the questions are just like the clues of what you should be thinking to solve the problem. And the more you get used to that, the more you can kind of decipher the question and see what the examiner is really getting at. So I would say right now, you're getting there. Now it's time to find past papers. Watch exam playlists on YouTube. I've got loads of GCSE and A-level exam playlists. Watch other people's as well, but don't just take in what the answers are. Think about how to solve the problem in front of you. So that's a really good suggestion for what you do as soon as I drop this live feed in about 5 minutes after I've gone through the last questions, is go to an exam playlist, watch it, pause it at times, think about what's coming next. And when you go through the explanation with the person, think, how have they solved the problem, rather than thinking what the answer is. I think that's a really important thing. I know I've spent a lot of time answering your question. That was, what's the best GCSE revision technique? And it's really about learning how to solve the problems rather than just getting some knowledge into your head. Okay, there's only so much knowledge you can fit into that lovely brain of yours. I hope that was all right. What else we got? Some really good questions. Are flashcards worth making or not? I've kind of said that, Maisie. I don't know if that makes sense to you. I would say yes, but I would prefer to see students using flashcards that exist. So why not buy that AQA set of GCSE flashcards, or use some that exist online, find some on TES, or download Primrose Kitten's flashcards, something like that, and use them. Because the idea of flashcards is that quick revision resources. That's why that BBC Bitesize app is so good, because it's that quick flick, and they have flashcards on that Bitesize app. My memorise equations for GCSE Physics, you could buy the book or you could buy the Kindle book, and it's designed as just flashing through the equations on your phone, rather than kind of sitting looking at a list of them, and rather than writing them out endlessly, which I think is a bit of a kind of, you want to avoid getting bored in revision. That's the most important thing. Okay, some great questions. If we're completely unsure but some of the topics, should we do practice papers and try our best to revise the topics and not do practice papers? I think you should revise the topic and then do some practice questions on it. So go over it for 10 minutes, just literally read through the book, then give yourself some past papers, some questions on it. Does that make sense? Oh, great luck on your pilgrimage and these holidays. But I've been working full on for the past few months. Is this a bad decision, my grades are? No, I don't think so. I think there's still time. I absolutely, when work gets busiest, that's when I really want to do my hobbies the most. Okay, and I'm not saying your religion is your hobby, incidentally, but I think the distractions are more useful than we kind of give them credit for. Is that okay? I think it's a really good idea to go on pilgrimage, but obviously that's your time off from study, if that makes sense. And I would recommend everyone to take some time off study during this period that's about to get quite busy. I'm taking my notes with me, and my schemes to memorise. Yeah, it sounds perfect, kid. Anybody got computer exam style questions? My school is subscribed, but my teacher just tells me to use resource sheets. Well, okay, so you need to maybe go and ask your teacher to spend, it took me like an hour, maybe an hour and a half, 2 hours actually, to sit and set my entire year 11 I set every single not past paper, every single little online on-screen topic test. So maybe go and, if it's not that person, go and sit and bug someone else in the department, the head of science or something like that, because they can sit. And now COVID have finally made us able to bulk assign you tests. So like we can sit and we can assign you like 40 at a time. I assigned, get this, 1,024 tests today. Okay, that doesn't mean like 1,024 kids. That is 1,024 to the entire year group. It means the triple scientists have got about 600, and the combined scientists have got about 400 tests. And I'm not expecting them all to do them all, but you know who's going to get the A stars and the grade 9s, don't you? It's the kids that will do the very vast majority of them. Okay, and the thing is that there's a lot of them take like 5 minutes, and a lot of them take a little bit longer than that. But I think that I think that a lot of them, I think that a lot of kids can work quite quickly through some of them and then take longer over the other ones. Okay, last few little questions and then I've got to go. Nice chat today, by the way. Well, if you don't have enough time, Jimmy, I know, mate. You can't do everything. And possibly, like, you know, I think it was like 600 kids got straight grade 9s. And that's a tiny percentage of like everybody out there last year. So don't expect to get grade 9 in every single subject. If you think to yourself, physics is for me, I want to do A-level physics, then you should probably prioritize that one. You know, like prioritize your English maybe and your maths. If you know that they're important subjects for you, prioritize one or two other subjects, because you can't do all of every single course, and I understand that. I'm not suggesting that everybody in their GCSE is doing like 10 GCSE or something like that. But actually, do you know, like once you get into the exam period, there's going to be, you know, subjects are going to start to drop away, and you're going to end up, physics will be probably one of your last, unless you do like further maths or something like that, or something else a bit obscure. But you'll be surprised how much time you kind of have once each subject kind of drops. Normally, normally kids find the real thing actually less stressful in a way than the mock exams, because there's a bit more time and there's a nice big half term in between. All right, so I hope that helps, mate. What do you think of the app 23 Equations? Never seen it, but I think they'll probably have a little look at that. I guess that's a good way to learn the equations. I actually even started making an app, but it just takes way too long, and I've got good IT skills, mad IT skills really, but I just don't think that I'm going to be able to make something that I'll be happy with. So I'm going to concentrate on some books. I'm trying to bring you guys some practice exam questions. Probably only be ebook, but the good thing will be free for you guys this year, and then it'll be a paperback sometime in September or something like that for next year. So loads of kind of past questions. There won't be past questions, there'll be questions that I've written. How much improvement can you make for AS end of unit tests and the mock test? If you've been getting C's and B's, can you get an A? You can get anything still, and yeah, C's and B's to an A is not beyond the realms of possibility. Oh, subjects drop, like you finish subjects, you know, like if you study art or dance, then you perhaps already almost be finished, you know, like and you certainly will be by the coursework deadline. So subjects, you finish certain subjects because you've done their exam. I got biology in double. I got biology in double. I got 51 in both tests, and to get a 9 in chem, I got 50 and 51, which is 9 again. Well done. Obviously, you just need to get the physics then. Yes, come on then. You're in the right place, because I am all about getting those highest grades in physics. It is to get a PhD, but a small step. How do I get very clear 9s? Yeah, be thorough. You've got to study everything right now. When your PhD is so different from a GCSE, because PhD is honed in on this tiny little aspect of physics, right? And GCSE is general. It's wider, more broad. You study a little bit of everything, but you need to have an understanding of everything to be the best specialist at the tiny little things. I hope that makes sense. Right, I'm going to go soon, dudes. Can you all like this this feed? Can you maybe, if you've finished this, if you can share it with somebody, that'd be really great. Any advice for my parents? My son is in year 10. Yeah, try and help them through this stressful period. Take them for ice cream when they look stressed. Encourage them. It is stressful, but at the same time, like help them to see the enjoyment of it. You know, like if your kids picked triple science or something, or then they kind of they pick that because they want to learn the stuff. You know, actually everything we teach kids at school is really, really interesting. Sometimes because we're in the stress of doing exams, we forget that, and the kids forget that. And I think encourage them to see the kind of love of it is a really, really useful way to think about that. Does that make sense, Nadia? I think like, you know, just encourage them to, right, well, why are you studying this? Why should you care about nuclear physics? Why should you care about this stuff? And it's not only because you want to get into the A levels, or you want to get onto the course or be a doctor or anything like that. It's actually because it's really interesting. I have a video, how to stay motivated, that I made right at the start of the year, so it might be worth checking that out. Another video that I thought I mentioned, I meant to mention earlier on, which is about one of mine, which is how to write an evaluation. It's a really good way to think about tackling those evaluation questions, so do that. What should we do if our teacher can't teach physics? No, good one. That's tricky. I'm not going to, I don't know who your teacher is, but yeah, there aren't many physics specialists out there. I think you're doing the right thing by looking at YouTube channels for teaching in physics, but I think you just need to practice. You need to trust yourself and trust the maths as well, which is a really important thing to remember in physics. All right, I'm going to go now. This has been that one thing that you need to do to get a grade 9 and an A star, which is to be thorough. You can do this. I gave some ideas for revision. One idea which you can go and do right now is to go check out my exam playlists, which are all linked in the description, or anybody's exam. But when you're watching exam playlists, exam question playlists, then go ahead and watch them, but think about how they solve the problems, not just what the answers. What are some effective ways? You can do it. You can do it, X-May, XAXM, mate. You can rock this. Effective ways to prepare for AS physics. There's loads of past papers for AS because it's been running for that year longer, so definitely time for past papers, and I will see you all later. All right, you can do it, X-May, AXO, X15. Yeah, I know, it's hard, right? But again, find the fascination. You're getting down about your A-level physics, your GCSE physics, definitely find the reason to love it, okay? Is it cars? Is it nuclear physics? Read on a little bit about particle physics, it's amazing. Look, is it stars? Watch some, you know, forget the GCSE physics videos maybe. Go watch Brian Cox about stars. Find that interest again, because I promise you, the reason we write all these things is because we think you want to know them. And if when we teach them, or when we write books about them and stuff like that for you to learn them for your GCSE, it comes across a little bit dry, right? Then and a little bit boring, then we've got it wrong. So go find the people who write about it just to keep you interested, the people who talk about it just to make you interested, and then bring that enthusiasm back to why you should bother learning them. Because if you want to do triple science, then you maybe want to go ahead and do A-levels and get into science degrees and things like that. And that's when it really starts to get fascinating. And if you want to get there, you've got to get on it.